So now we will discuss about scalar triple product of vectors. Okay, so what is the definition? So let A, B and C are three vectors. Okay, then scalar triple product. Okay, scalar triple product means product means multiplication, triple means there are three vectors, and scalar means we get output is scalar quantity. Okay, so scalar triple product of three vectors is denoted by A cross B dot C. Okay, means these are A and B, so cross product of A cross B is again a vector quantity. This is a vector quantity and this is vector. So dot product of two vector is a scalar quantity. Okay, so this is the basic idea of scalar triple product. Means let A, B, C are three vectors, then by taking cross product A cross B, so this is a vector quantity and this is a vector quantity. So dot product of two vectors is scalar quantity. So this is the basic concept of scalar triple product of three vectors. Okay. So now what is A cross B? So as we know, A cross B is cross product of two vector. So we have if A is equal to A1i plus A2j plus A3k, B is equal to B1i plus B2j plus B3k, and similarly C is equal to C1i plus C2j plus C3k. Okay, so A cross B is equal to, by the definition of cross product, here I, j, k, A1, A2, A3, B1, B2, B3. So A cross B is equal to I, A2, B3 minus B3, A2 minus j, this is A1, B3 minus B1, A3 plus k, A1, B2 minus A1, B2 minus B1, A2. Okay, so this is a vector quantity. So now A cross B dot C. So as we know, dot means this is C. So this thing dot C. So this is equal to, we have I dot I1 and I dot J0, I dot K0. So this is A2 B3 minus B3 A2 into C1. Okay, and this is minus A1 B3 minus B1 A3 C2 and plus A1 B2 minus B1 A2 C3. So this is A cross B dot C. Also we have determinant. Okay, so this can be written in the form of determinant. So A1, A2, A3, B1, B2, B3 and C1, C2, C3. Okay, so this is same thing. Okay, so dot scalar product of three vectors defined as A cross B dot C, and the value of this thing is determinant A1, A2, A3, B1, B2, B3 and C1, C2, C3. Okay. Now geometrical interpretation of scalar triple product. Okay, so I want to say first we will explain for two vectors. Okay, so we have in the case of two vectors cross product. means if A and B are two vector, then cross product of A and B is denoted by A cross B. A cross B is again a vector, okay, and direction of A cross B is perpendicular to the plane lying A and B, okay. So this is the direction. This is the direction of A cross B, because A cross B is equal to mod of A mod of V sine theta unit vector n. What is theta? Theta is angle between A and B. So direction of n is perpendicular to the plane, this plane, okay. This is the direction of perpendicular of the A cross this plane A and B, okay. So A cross B is this thing, and this is again vector quantity. Also we have area of parallelogram is mod of A cross B, okay. So this is parallelogram. So what is the area? A cross B, mod of A cross B. Similarly, in the dot product, if A and B are two vectors, then dot product is a scalar quantity, and A dot B is equal to mod A mod B cos theta. This is scalar quantity, and this is vector quantity. So this is the difference between scalar product and vector product. Vector product is again a vector quantity, but scalar product or dot product is a scalar quantity. So here, if A is equal to A1i plus A2j plus A3k and B is equal to B1i plus B2j plus B3k, then we have A dot B. What is A dot B? So A1 B1 plus A2 B2 plus A3 B3. Also, you have seen in before classes in school level, so this is very easy to see. And similarly, A cross B can be explained in determinant form, okay. So this is A cross B. So now geometrical interpretation of scalar triple product, okay. So let A, B and C are three vectors, okay. So this is a parallelepiped, okay. This parallelepiped contains six plane. One is this plane on surface, and this is second parallel to the surface, okay. This is second, and this is parallel to the, and this is and this same, okay. So there are six planes. As you know, cuboid, so cuboid also contains six plane. So by these three vectors we get a parallelepiped, okay. So what is the volume of parallelepiped? We have the area of surface, okay, into height. So what is height? So what is the area? So area of parallelogram, okay. So parallelogram means A cross B, mod of A cross B. As we know, area of parallelogram by vectors rule, if A and B are two vectors, then area of this parallelogram is mod of A cross B, okay. And what is the height? So height is, so as we know, if A and B are two vectors, so A cross B, so A cross B is equal to AB sine theta unit vector n. So direction of A cross B is perpendicular to the plane, okay. This is direction A cross B, and this is C. So C and A cross B, angle between C and A cross B is theta. So this is the height. What is height? C cos theta, okay, because A cross B is nothing but unit vector in the direction of A cross B, okay. So this is the volume, area of base into height. Since base is parallelogram, so this is the area into height, C cos theta. This is height, okay. This is the C, and this is the unit vector, because A cross B is equal to AB sine theta unit vector n. So direction of unit vector n is same as C, okay. So this is the height. So this is A cross B C cos theta, and this can be written as A cross B dot C, okay. because dot product of two vector A cross B is a vector, C is a vector, so dot product of two vector is a scalar quantity. Okay, so this can be written in determinants form, this thing. Okay, so this is the interpretation of three vectors. Okay, so you see here, very interesting that if these three vectors A, B and C are coplanar. What is the coplanar? Means this plane lies the same. Okay, means vector 3, vector C lies also in the same plane. Okay, like this type. Means this is A, this is B and this is C. Means these are coplanar. So if these are coplanar, then automatically volume of parallelepiped is 0. Okay, it means A dot B cross C is equal to 0. So this is the geometrical interpretation, which is very easy. Okay, now A cross B dot C is equal to this thing. So some important properties. Okay, so now properties of scalar triple product. So as we know, the definition of A cross B dot C, it means scalar triple product. So first property is A, B, C. This is the scalar triple product. Okay, so is equal to BCA, okay, is equal to CAB. Means these are equal if we change cyclically. Okay, also the notation of A, B, C can be written as only A, B and C without comma. Okay, is equal to BCA. Okay, is equal to CAB. Okay, so this is the first property. Second property is if we interchange AB is equal to BA, so this will be minus sign. Means second property is ABC is equal to minus BAC, because A cross B is equal to minus B cross A, since A cross B is equal to minus B cross A. Okay, and third property is if two vectors are equal, then we have, if two parallel vector, then A cross A is equal to 0. It means A B is equal to 0. Okay, it means if there are three vectors, so if any two vectors are equal, then value of scalar triple product is 0. Okay, you can also verify it by the property of determinant, because you know A cross B dot C is equal to this thing. So if two row or column equal, then determinant is 0. Okay, so you can verify by property of determinant. Also, if one vector is parallel to other, means A vector is equal to lambda B, then also in this case A, B, C is equal to, so A is equal to lambda B, so here lambda B, B, C, and in this case lambda is outside, so B, B, C is equal to 0. Okay, so this is very important that if area of parallelepiped is 0, area of volume of parallelepiped V is 0, it means this is 0. Okay, and if ABC is 0, then volume of parallelepiped is 0, it means A, B and C are coplanar. So this is the condition for three vectors A, B and C are coplanar, then volume of parallelepiped is 0. It means this value determinant of three vectors A, B, C is 0. So this is very important property. So this is an interesting problem. If there are three vectors A, B and C, then find the volume of cuboid. Okay, so as we know, in the geometrical interpretation of three vectors means scalar product of three vectors. So this is geometrical interpretation, means this is vector A, this is B and this is C. So this is parallelepiped is nothing but cuboid. Okay, so if we need to calculate the volume, so what is volume? Volume is equal to this thing ABC. Okay, this is determinant. So this is very easy to see here. Volume V equal to ABC, and this is equal to A1, A2, A3. What is A1? Here 1, 1, 1. What is A2? 1 minus 1, 1 minus 1, 1, 1 minus 1 and 1. And what is A3? So 1, 2 minus 1. So this is very easy because this is a simple determinant. So this equal to 1, 1 minus 2 minus 1 minus 1 minus 1 plus 1, 2 plus 1. So this is minus 1 minus 2 minus minus plus 2, 2 plus 1, 3. So 3 to 5 minus 4. So this is volume for cube unit. Okay, so this is the volume. So if you have any problem, means if given three vectors, so you can calculate A, B, C very easily. Okay.